Seventh graders, so let me review the divisibility rules with you. These are the ones that we worked on last year. And it's the first lesson in chapter 4. Chapter 4, you're going to be learning and reviewing fractions, factors, multiples, and simplifying and doing problems with fractions in them. So, in order to be able to simplify fractions, you have to know how to reduce them and know which numbers are divisible by other numbers. So, the rule for 2, if the last digit is even, so every even number other than 2 is divisible by 2. Okay? How do you know if it's even? Matt?
How do you know if it's even?
How do you know if a number is even?
Because you look at the last number.
And if it is a
Like odd, then.
a 2
Oh, then it's even.
or
Yeah, look at it says it's a multiple of 2 is even.
that's right, if it's a multiple, how do you know if it's a multiple of 2? So if the last digits, Matt, so if the last digits are 0, 2, 4, 6, or 8, then the number is even. Think about it.
What about
4, like 14, 12, 16, 18, 20, 22, 24, they all end in either a 0, 2, 4, 6, or 8. The rule for 3, in order to tell if a number is divisible by 3, without just dividing it out, you can add the sum, or just add the digits, or find the sum of the digits. So if you have the number 189, if you add 1 plus 8 plus 9, that equals 18. And since the sum is 18, Matt, you're going to need to move back up here today. Back to your original spot.
He's not asking me.
I know, that's why you'll have to move, and then if you'll have to move to then.
Or you
Go back
can
to
just
your
move
original
mine.
spot. No, I'm going to move you back. That would be fair. So Matt, back up there, Bennett right here. I said we'd only, this would be a test period, and you guys aren't paying attention. So, if the sum of the digits is divisible by 3, then the number is divisible by 3. Since the sum of these digits are what? Pointing at it. 18. The sum of these digits, when you add them together, 1 plus 8 plus 9 is 18. Since 18 is divisible by 3, then 189 is divisible by 3. No, that's not. No, look. If the sum of the digits can be divided by 3, then the number is divisible by 3. The same rule applies to the number 9. If the sum of the digits are divisible by 9, then the number is divisible by 9. So, is 189 divisible by 9? Yes, because 18 is divisible by 9. How about 343? Is that divisible by 3 or 9? What's the sum of the digits, Andreas? 343. Yeah. Equals 10. And is 10 divisible by 3? No. So is 343 divisible by 3? No. What about 342? Would that be divisible by 3? Well, add the digits. Are you listening? So add the digits, 3 plus 4 plus 2. What's 3 plus 4 plus 2?
Wait.
Yeah, 3 plus 4. Oh, plus 2. Plus, okay, so 9. Yes.
It's 9. So that's divisible by 3.
Yes.
Would it be divisible by 9?
Yes.
Why?
Because 9 divided by 9 is 1.
Exactly, because 9 divided by 9 is 1. The sum of the digits are divisible by 9, so the number is divisible by 9. Okay? Ready? Question about the rules so far?
No.
Okay, then just hold your other questions and I'll get to them as soon as I'm done going through the notes, okay?
Well, I just have a question about, I guess.
Okay?
So are you saying that if the number has no remainder, it's divisible?
Right, yes, divisible evenly, without a remainder. That's right. Or without a decimal point, if you're using your calculator. Without a decimal point.
Well,
Are you paying attention? Now, how about the rule for 5? What's the rule for 5, Trevor?
if it ends in a 0 or 5.
Yep, if the number ends in a 0 or 5. Think about it. 5, 10, 15, 20, 25, 30. They all either end in a 0 or a 5. And then the rule for 4. The rule for 4 is if the last 2 digits are divisible by 4. If the last 2 digits are divisible by 4. So, if you think about the numbers that are divisible by 4, like 4, 16, 24. So if they end in any of these, 24, 28, 32. If they end in any of these, then the number is divisible by 4. 40, 44, 48, 52, and so on and so on.
60.
Those are all multiples of 4. So if the numbers are divisible, if the number ends with those last 2 digits being divisible by 4, then the whole number is divisible by 4. Okay? Then there's also a rule for 8. And along those same lines, if the last 3 digits are divisible by 8, then the whole number is divisible by 8. So like this number, 146,323,664. That number is divisible by 8. Because the last 3 digits, 664, these 3 digits, oops, that. These 3 digits, not those 3 digits, these 3 digits are divisible by 8. We already talked about the rule for 9. What was that again, Jack?
If the sum of the digits are divisible by 9.
Right. How about the rule for 6? Matt?
If the number is divisible by 2.
Yeah. So if it's divisible by both 2 and 3, then the number is divisible by 6. So how do you tell? Well, first of all, if it ends in an even number, then it's automatically divisible by what? Tyler? If the number ends in an even number, then it's automatically divisible by 2. How do you know if it's divisible by 3? Then what do you need to do to check?
Yeah, if all the numbers and then it's divisible by 3.
Yep. So I give this example. Is this number divisible by 3? Bennett?
Sure.
2 plus 4 is
6.
plus 8. Plus 8 is 14. Is 14 divisible by 3?
No.
No. So, is this number divisible by 6? No. Why, Nate?
Because 14 cannot be divided by 2.
Right. It is divisible by 2 because it ends in even, but it's not divisible by 3 because the sum of the digits are 14, and that's not a multiple of 3. Are you with me here?
I know.
Yep.
I'm going to win this.
All right. So do 1 through 21 for tomorrow.